Okay, now I was looking over the um, analysis of, and we're making histograms in the first part. And I noticed the video is chopped off somehow. It doesn't show some important basic stuff. Anyways, you can see here where, in this case, we took 50 measurements, and so there's our measurements there. And there's our background. We got 180 counts over 5 minutes. So that was 36 counts per minute, or 9 counts for 15 seconds we did here. I forget where the 12 seconds or 15 seconds comes from. But anyways, I also then right away, you see here, the count number minus the background per 15 seconds with the dollar sign. So it affects it's always the same background. And then I have my fill handle. And there we go. So we have to calculate a few things. So, of course, the beauty of the spreadsheet, let it do all the boring stuff. So first of all, we needed the average of all them guys. I have the dollar signs there just so I could use the drag handle. I didn't see it's just on the numbers themselves, because then I can use the drag handle and pull it over here. And you see now it's doing that column because I didn't have a dollar sign in front of the letter. So then we can let Excel give us the standard deviation of the sample, and we could calculate our own standard error, which is the standard deviation of the sample divided by the square root of the number of counts. And I know there's 50 of them, but I use the count function, so that way I could use this spreadsheet over and over. I can just type in different data sets, and then my equations would still work. And then a Poisson distribution is supposed to have a standard deviation of the square root, and they did that. And then this is I don't know what to call this. This is they call it in the manual, which I got to fix. Where'd it go? Here it is. The standard deviation of the mean value, and that's dumb. I got to get rid of that. Excuse me. Whew. I'm coughing up crap from my lungs. Whatchamacallit? Right. Theoretical standard error. Okay. And now they're ready to compare for you. And an average is an average. There's nothing special about that. And you see, basically, I subtract 9 counts, and my average is going to go down 9 counts, right? It has little effect on the standard deviation, though, which is what I would expect. Little on this theoretical right here. Interesting. Well, theoretical. It just means this is Poissonian, and this is just basic statistics. We're not going in deep enough for you guys, I'm happy if you understand standard deviation and when to use it and what a normal distribution is, the bell curve. When the time comes that you're doing a counting experiment and you just say, all right, you know what, I got to double check how to calculate some of these things. That's what I hope that you'll take away from the class. And if we're going to get to that because the other ones have error bars. The graphs have error bars, and that's the square root of the measurements. That's what's sweet about Poisson. You don't have to do any special gymnastics to calculate the error on a data point. Okay, so I need to make a histogram. So I need to know the range I have to cover. So I use the min and max function to find out the smallest and largest entries here. So I have to cover from 185 to 238. So they said to try a bin width of 4. So then I'll increment this number by 4 to 170 until I see 238, 242. So now I've covered the whole range, min and max. I could have done it every 2, but with only 50 samples, that's probably not a useful bin width. It's the smaller you make the bins, the less number of entries you get, and then you just see a bunch of graphs. And I'll explain that more when I have an actual graph in front of me. Now, Excel has a histogram function. It's not very useful. We're going to use a neat function they have here because it gives us lots of leeway. And with Excel's been updated a couple times since I did this, but we're going to see something interesting. But anyways, I'm going to put this in my first place where I'm going to put this. I have to put the same function in every one of these cells. And you used to have to use a thing called an array, but just watch what happens. Okay, so we're going to use the frequency function. So f frequency, yep. And then it wants to know what's the data it's going to look at. And then it wants to know, and you have to put a comma there. Oops, escape. That didn't work out. Equals frequency, open parentheses, and we select the data. That's it. And then we hit comma, and then it needs to know, it says bins array. What it wants is the bin edges. And so this is my set of bin edges. And this is, I'm gonna take care of that later. My phone is ringing. These are in economics. So this is a spreadsheet. It's based on economics. And this is the upper edge of a bin. And so first of all, I select those. Then I close the parentheses and hit enter. And this is a new feature. Look how it filled in all those values, although I don't know why it put one there. But this thing is telling me, so here, with an upper bin edge of 206 and the one below it is 202, so this is the number of times that a count here is from greater than 202 and less than or equal to 206. So if the count number is 202, it doesn't go in this bin here, it goes here. But if it's 202.0001, then, well, this one's easy because it's integers, right? So basically, this is from 201 to 206. And if it's 206, it stays in this bin. Oh, what did I say? 201, excuse me. 203 to 206. So the bin edges, the upper edges, are inclusive. So any one of these bin edges, if the count is 210, then it goes into that bin. But the, wow. Another phone call. I get so many robocalls, I hate answering. Now, for the moment, I've just put some placeholders here. And we'll get to what this is going to be for our x-axis. But at the moment, we may adjust these numbers here. So there's no quick way to make these labels. So we don't want to go to the trouble of creating those until we know exactly what our bins are going to look like. And I will go ahead and put nice borders. Okay, so this is a little weird, but the way you do this is you only select this because, this is written in economics. People wrote this, so I don't know why you don't select both columns. And let's see. So we're going to make sure you can see this. Let's see. Yeah, I made because my screen is so huge. I want to make sure that you guys can see on your, it doesn't look tiny on your screens. Okay, so I'm up to this insert menu, and I want a column graph. And bingo, there it is. Now, one thing, though, that's a little weird is that it doesn't, even though you can see 1, 2, 3, 4, I don't believe, let's see if I call this 10, 20, and I change these, and nothing happens. So what you have to do is you have to go into select data, and that's the horizontal the categories. And so now instead it just arbitrarily assigned 1, 2, 3, 4. And in fact, you could, if you were really if you had lots of patience, you could actually individually type these if you wanted to. But this is a spreadsheet, right? So we're just going to select our labels over here. And OK. And then you see there they are. Now, notice that this doesn't have a lot of shape. And so one thing I could do, just for the fun of it, let's see. Let's go with 180, 182. Oops, that's weird. 182, and then so now you notice that, and I don't even cover the full range anymore. And it's very difficult to see structure there, right? So we can start out with their suggestion of a bin width of 4. Or maybe we could go with a bin width of 5. And notice now you begin to see a shape. And, well, we don't know. Let's see. The average is 211. So that's about, oh, look at that, number 90. Isn't that interesting? 90 to 100, right there. So I would call that the average myself. Now, one thing about this, you might not find this pleasing. So, oops. Yeah, let's see. We need to go to the format area here. And there it is. So, I'm just looking at I have a green box on my screen to make it what you can see. This tells me what you can see. Okay, so I want to go to series count and go to the bar graph here. And I'm not quite sure I understand these numbers, but I see if I go to 0, then there's no gap between them. So I guess it's nice to have a little bit of gap. I honestly and truly don't know what this does. Series overlap. Oh, I know. There's only one series here. So that's if I had two series. Right. Do we want the... Oh, I get it now. Right. I forgot. They were thin because they're assuming you're going to put different data sets, not a single histogram. See, this is not a histogram. This is a bar graph. Okay, now I get it. Maybe, I want to open the gap. I'll say 10%. And now you see you get a more pleasing look, what you expect a histogram to look like. And you see 8 members there. So let's assume we like this, right? So remembering that let's see, this would be less than 170. 170. And then the next one is going to be 170 to 175. And you see how that's kind of tedious. I have yet to figure out how to speed up process. There may be some way of doing it. 175 to 180. Now, of course, another way you could do it is pick the middle of each one. That's something that some people do. Although, let's think about this for a minute. So the 175 is actually, it doesn't include, and in our case, you could call this 171. That's something that you have to scratch your head over, right? Because 170 won't be in that. 170 will be in the one before. Okay, and then 175 will be in. It's because it's easier when they're the lower edges, but we have to deal with what we have, and Excel is upper edges. And notice that Excel has rotated these already for us. But for example, distance from axis, let's see. Where is rotation? Oh, here we go. It's kind of weird. You have to go to different places. And this is a counterclockwise. Where'd it go? Oh, no. Where do you specify that? Angle, oh, it's fixed. Okay, angle clockwise, yeah. You can't do anything, but I like the counterclockwise. It just, because if you put them horizontal, then they'd overlap each other and you wouldn't be able to read them. And of course, just as any graph, you can jazz this up. Okay. Now, just in case that your Excel doesn't behave like mine, let me show you one other thing. Let's see, what does the, let's see, plot a histogram. Right, so showing each of the lines as well as numerically. I'm not quite sure what that means. I haven't fixed everything. But you can, I actually don't know how to have Excel put a line in this. I know how to do it in a scatter graph, but for us, we can just go to, let's see, insert, let's see, where shapes, here we go, line, and we can draw a line. And I think that's vertical. And then we know the average is 211. We have to finish doing our bin widths. So we can figure out where exactly, right? Because if it was 177, I could put it in the middle of this bin, for example. So it might be in the middle, it might be on the edge. Of course, it looks like a different color would help so you could see it better. Excuse me. There we go. And you can add labels. Now, of course, one drawback of this, oh, look at that. Used to be if you put the line there and then move this thing, the line would be independent. Sweet. They finally, I wonder how many people have complained. Okay. So, all right, we got a text box. So this is the numerical average. I took the average of them all. That's the numerical average. And, okay, where'd it go? There it is. Now, is that going to stay there too? Look at that. Holy crap. Okay. Right, okay, so I'm surprised I didn't ask. They tell you to, it says 68% of the entries are supposed to fill. You know what, it isn't there, and we're at the end of the semester, so I'll have to fix that up for next time. Okay, so that's all you need to satisfy the conditions of the lab manual. And of course, make this pretty, and then you print this and paste it into your logbook. And in this case, yeah, there's a report on this part. Okay, so I think I've hit it all. So I'll get this up onto YouTube.